Welcome to the Transum Podcast, a monthly roundup of the new features on the transum.org website, providing mathematical puzzles, games, learning activities, and the ever-popular mathematics lesson starter of the day. Here's your host, John Tranter.
Hello and welcome to podcast number 108 for the month of November 2023, a month containing a rare opportunity to enjoy a unique Fibonacci day, because the date on the 10th, when it's written as 10-11-23, represents a strange representation of the Fibonacci sequence, because each digit is the sum of the previous two, but it doesn't start where Fibonacci sequence normally starts. So 1, 0, 1, 1, 2, 3. Yeah, that is follows those rules, so there you go. I wonder if anybody else will notice that. That's on the 10th of this month. Okay, that's enough exciting news for today, so let's get on with the puzzle of the month. How many positive two-digit numbers are there whose square and cube both end in the same digit? So have a little think about that. Please let me know if you get a solution and how you arrived at the solution. And perhaps trying all of those two-digit numbers isn't a good idea. So anyway, get in touch if you can find a solution to this month's puzzle. So while you think about that, here are some of the key resources added to the Transum website during the last month. All for One is a new puzzle requiring you to create three fractions that combine with addition or subtraction to make one. The idea from this puzzle came from Chris Smith's wonderful weekly publication, the Grange Academy newsletter. Now, I created levels 1 to 4 just as sort of a warm-up or a preparation to get you ready for the big level 5, because that's the difficult one. So levels 1 to 4 are much easier. They have clues. But level 5, well, you're by yourself. How many of each? Well, that's not a question. That's the title of another one of the Transum activities, and it's now got a level 2. I created level 1 to match the national curriculum statement. Pupils should be taught to find pairs of numbers that satisfy an equation with two unknowns. The new level 2 extends this idea to 3 or more unknowns. Divisibility tests has been updated thanks to a prompt from subscriber Sharon, who wrote to me saying,
I hope that you are well and that the school term is going well for you. We continue to enjoy using Transum with our students here at DCB. Today I was using the divisibility test task with my year 7s. I encourage my students to not wait until the end to click the check button and to get regular feedback as they're working on whether their answers are correct to make sure they're not repeating a mistake lots before they find out. It's a feature I really like in Transum. When using the divisibility test task, this created a problem though, that because any that had the correct answer to not tick any, they got a tick for these when they were checking the first answer. I don't know if I'm the only one that encourages my students to check answers as they go, and so if this is only an issue for me, but if others do the same, it might be helpful to add a box that has to be ticked for not divisible by any to get the tick. I hope this is helpful feedback.
Okay, thanks, Sharon. So your wish is my command, so it has now been done. The divisibility tests now works a bit differently to overcome that problem. So the links to all the things I'm talking about here in this podcast can be found at transum.org/newsletter. So please do go and have a look, have a play with them, and if they're suitable for your students, there you go, free to use. The triangle solver has been updated, and well, I felt it sort of needed a bit of a disclaimer or a warning to students. So the following very formal statement has been added.
This tool is designed to enhance your understanding of trigonometry and to validate your calculations. While it can provide answers, solely relying on it for your homework bypasses the valuable learning process. We encourage you to first attempt your assignments independently, then use this app to verify your solutions. If discrepancies arise, consult with your teacher to bridge the gaps in your understanding. Remember, the journey of learning is as crucial as the destination.
You can find Transum Mathematics at www.transum.org.
ChatGPT now has eyes. Once again, my experimenting with artificial intelligence has yielded impressive, though not necessarily correct, results. So I was creating an exam-style question about a speed-time graph, and I had an idea about what I wanted the shape of this graph to look like. So on a piece of paper, I did a quick sketch of this sort of curve and photographed it and uploaded it to ChatGPT. I wanted a version that I could type into, sort of an equation that I could type into Desmos to produce a nice version of this graph. So I asked it, could it give me an equation of this sketch? So amazingly, it had a look at my sketch and it came back with...
The graph you've provided appears to be a combination of linear and polynomial segments. While it might not be possible to exactly reproduce the curve using a single equation, I can offer a rough approximation using piecewise functions. Here's a piecewise function that could roughly produce a similar shape.
So do have a look in the newsletter, transum.org/newsletter, to see what ChatGPT came up with. But I got very excited about this. The fact that it can see diagrams, amazing. Yeah, there's a ray of hope. I mean, it did make a reasonable attempt, even though it got it wrong. And I think in the future, this could be something that we take for granted as the technology continues to develop. So stay tuned, watch this space as I continue to explore this remarkable artificial intelligence that's come about in the last year or two. On the 5th of November, you can enjoy Bonfire Night excitement. I remember it was a big deal when I was growing up in the UK. I remember adverts on the TV for fireworks. Remember the 5th of November for gunpowder, treason and plot. And then something else, the last line I have forgot. But anyway, there's a theme starter for the 5th of November. It's called Firewords. And as I'm recording this podcast, I'm just about to start to add some clues to the Firewords starter as what some of the words that the pupils are expected to find might be. I think that will make it more accessible to more pupils. Finally, the answer to last month's puzzle, which was... write 1 million as the product of two numbers, neither of which contains any zeros. The first 5 people to send me correct solutions were Martin Wright, Chris Smith, Anne Roberts, Alan Christie, and Mikas Legsdins. I'm sure I've made a very bad attempt at pronouncing Mikas' name, so do please forgive me. Anyway, thank you to those people that did contact me about the puzzle. It was great to hear from you. I really do appreciate that. So keep it coming, and if you can solve this month's puzzle, again, please get in touch. Anyway, so how do we get the solution to find these two numbers, this unique solution? Well, I think the key to it is to realise that 1 million is 10 to the power 6. And 10, of course, is 2 times 5. So the prime factorisation of 1 million is 2 to the power 6 times 5 to the power 6. So the two factors, the two numbers that we're looking for that multiply together to give 1 million, must have some of these 2's and the 5's within them. But if you combine a 2 and a 5 in the same number, 2 times 5 is 10, so that will give you a 0. So we can't combine the 2's and the 5's in the same number. So the only solution is taking all the 2's, all 6 of them, multiplying them together to give the first number. Take all the 5's, all 6 of them, multiply them together to give the second number. So the answer is, the first number is 64, the second number is 15,625. Great puzzle. And Will, the editor of Mathematical Pi, he wrote to me to say that that same puzzle had appeared in Mathematical Pi a number of years ago. But actually, there can't be many puzzles that haven't appeared in Mathematical Pi. It's a newsletter that's been going for as long as I can remember. So, yeah, what a great resource that is. Oh, and finally, I had an email from Rick Blair who said that he cheated and wrote a Python script to solve the problem. And he's presented it, and I've put it in the newsletter as well. That's just interesting. But I'm writing JavaScript routines, functions all the time to check solutions to problems that I put on the Transom website. So yeah, it's a great skill to be able to write these little programs. Okay, that's all for now, apart from to say I could tell you a joke about 288, but I won't, as it's too gross. Bye.
Thank you for downloading and listening to the Transom podcast. You can find the website at www.transom.org, where you're welcome to use all of the activities absolutely free, or jump in with both feet and become a Transom subscriber.